All right, so I wanted to do this problem, and it takes a little longer just for me to explain it. All right, so we just want this one's kind of counterintuitive because permutations and combinations is a type of probability, and so when I tell you how to do this, you're going to think it should be like the opposite way around. So I'm trying to get... Okay, how many ways is going to be, like we did these up here, and it said how many different possibilities. All right, and if I said, okay, what is the probability that it's 2 musical plays, pick 9, then you would do 1 over 72. Okay, and so that's how this is related to probability. All right, so first we figure out how many letters there are total. And then we figure out the different letters. So there are 1, 2, 3, 4, 5, 6, 7, 8, 10. There are 10 letters total. Doesn't matter if they repeat. And then different letters. There is an S, a T, an A, an I. Then S repeats, T repeats, I repeats, C, and then S. All right, and so we just learned about factorial. So we would do 10 factorial over, okay, S. There are 3 of those. T, 3 of those. A, there's 1. I, there's 2. And C, there's 1. And so we're going to do 3 factorial, 3 factorial, 1 factorial, 2 factorial, 1 factorial. Couldn't really fit it there. Okay, I'm just going to plug this into my calculator. So, and what is thinking? Okay, 10 factorial. Oh, all right, so big. 10 factorial is 3, 6, 2, 8, 0, 0. 1 factorial is 1. 3 factorial is 6. 3 factorial is 6. 1 factorial is 1. 2 factorial is 2. And so I'm going to take that 3 million number and I'm going to divide by 1 times 6 times 6 times 1 times 2. Right? And I get 50400. So when order matters, we can make 50,000 different letter combinations. And so because it's permutation and so order matters. So for example, the letters we had to choose from are these. So for example, S-A-T, when order matters, is totally different than P-S-A. These are not the same when order matters. When order doesn't matter, they're the exact same thing. All right. So now let's talk about permutation. Order matters. Combination order doesn't matter. And so, like when you have a combination lock, like on your lock or whatever, I don't know, maybe it's 22, 7, 34. Okay, that is the exact same as if you turned your combination lock and you did 7, 22, 34. It would still open the lock. So that's why a combination lock should be called a permutation lock. And so there's a formula, okay? I'm going to show you kind of like the shortcut and then how to do it on the calculator. And then you can decide, or you could also just plug in the numbers to this formula and go from there. So an advertising exec wants to select 3 different pictures for a flyer. She has 10 to choose from. How many ways can she select them? She has 3 total. and she has 10 to choose from. So the first one has 10 choices, the second one has 9 choices, the second one has 8 choices. And because order doesn't matter, we're going to put a denominator on these guys. So 10 times 9 times 8, 720. 3 times 2 times 1 is 6. And so we get 120 ways. If order mattered, it would be 720, because you wouldn't do that bottom part. All right. Example 10, how many combinations of 10 are there taken 3 at a time? This is the exact same question, except this is a word problem. And this guy is really 10 combo 3. And so let me show you. Type 10 and then math. I'm going to go over to probability, and now we're at combination. And then 3, and so I get 120. So it doesn't matter if you want to do the shortcut or you want to do the calculator. I just need you to understand what all this means. This means there's 120 different ways to select 3 different photographs when order doesn't matter. All right, here's another one. In the club, also, hang on, let me go back. Most things, so I will always tell you if order matters, order doesn't matter, or there'll be some sort of phrase where you know. And then most things, order doesn't matter. So for example, you're playing poker. The order of your cards doesn't matter. You can still get like 3 of a kind, and then 2 other cards that are random. And that 3 of a kind, they can be sitting next to each other. They can be in the middle. They can be spread out, so it doesn't matter. So passwords, license plates, those kinds of things, your order matters, because you can't tell a police officer, oh, I think the license plate was ABC, when it was really BAC or something. But I'll tend to tell you. Otherwise, it will be very obvious. So in a club, like, I don't know, train club enthusiasts, I have no idea. Okay, so in a club, there's 7 women and 5 men. And the committee, there's a committee, okay, of 3 women and 2 men is chosen. Okay, we have women, men. And so for the women, there is 7, combination 3. And then for the men, there are 5, combination 2. Right, 7 and 3. And then 5 and 2. So that's how I got those. How many different possibilities are there? So you have a committee. It doesn't say like president, vice president, secretary. It just, we have a committee of these people. And so order is not going to matter here. You can do the shortcut. So 7, combination 3, we draw 3 spots. Then we go 7, 6, 5, 3, 2, 1. And then the men, we would do 5, 4. After we did 2 spots, then we would do 2, 1. And we would multiply 7 times 5 times 5 times 4. Write that number. Divided by 3 times 2 times 1 times 2 times 1. Or 7, we can do 7 and 3, 5, 2. So 7, 3, 5, 2. And it's 350. There are 350 different possibilities to get that committee. So if this had said a committee of a president, vice president, secretary, and a treasurer, and like it told you specifically who was on the committee, then order would matter. But here they just want some people to make decisions. All right, great. There's a couple more things I want to discuss. One more. Oops. Oh, okay. All right, what if we had 8, choose 3, 8, choose 3, and we did combination versus permutation. So 8, permutation 3, 1, 2, 3, so it would be 8 times 7 is 3. Oh, no, I'm sick, silly woman, 6. All right, and we get 3, 3, 6. Different ways. If it was 8 combination instead of permutation, 3, it would be 3, 8, 7, 6, and then divided by 3, 2, 1. Or you can type it in the calculator, and I get 56. So I want to discuss really quickly why permutation has so many more choices than combination. In permutation, the numbers 1, 2, 3 is different than the number 3, 2, 1. And so I count those twice. Just like I would count 2, 1, 3 different than 2, 3, 1. Those are all, like, that's 4 different ways over there. For combination, 1, 2, 3, 3, 2, 1, 2, 1, 3, 2, 3, 1. All of that is only one way because it's the same exact, it's the same exact numbers. So permutation is going to have more because the order matters of the numbers. And combination is going to have less because you're not going to double count these. You've already used the numbers 1, 2, 3. All right, so go do your practice work, and I will talk to y'all later. Bye.